Hello students, in this session we shall discuss chapter 10 of class 10 science, that is light, reflection and refraction. Okay, so already you have got an idea in previous classes, in lower classes, what is light and what is reflection and refraction. You are acquainted with the laws of reflection and refraction. Well, we shall recall this. See, in your book these laws are given. See, the angle of incidence is equal to the angle of reflection. Angle of incidence is equal to the angle of reflection. And number 2, the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. So these laws are applicable actually. These laws are applicable in all types of reflecting surfaces. Okay, so let us just recall this. First we should consider in case of plane mirror. Suppose this is a plane reflecting surface and this ray is reflected here. This ray comes incident and get reflected this way. You see these arrow mark is I am showing. So at this point it is incident and reflected back. And at this point, if we draw a normal to the plane, normal that is perpendicular to the plane in which it is incident. Alright. So this makes an angle. This ray makes an angle with the normal. It is angle of incidence I. And this is the reflected ray. This makes an angle. This also makes an angle with the normal. This is R. Angle of reflection. Angle of incidence. Angle of reflection. So as per the law, angle I equal to angle R. Angle of incidence is always equal to angle of reflection in any plane reflecting surface. And it is also in case of any reflecting surface. And number 2, see the incident ray and the reflected ray and normal to the plane all lie in the same plane. It is this is the same. If it is a plane mirror, suppose if I draw like this. So this we can consider a plane. This is nothing but a plane. In the same plane all the points are lying. This is the number 2 part, the second part of the law. So first we shall discuss the plane. In case of plane mirror, you see there are two types of mirror in this chapter. In the section of light to discuss, we come across two types of mirror. One is plane mirror, another is spherical mirror. Though many more plane reflecting surfaces are there, but we are starting with the mirrors. So first we shall discuss plane mirror. Plane mirror, you have seen in your home also. Suppose this is a plane mirror. In your dressing table, in your Godrej, the plane mirrors are attached. You can see this. So this is the plane mirror and this is the back side of the mirror. So there are some properties of the plane mirror, you see. First, the size of the image is equal to that of the image object. Suppose this is the size of the object is equal to the image. This is the object placed in front of the mirror. So the image will be formed in the virtual image is formed. In case of plane mirror, the virtual image is formed. The image is always virtual and erect. So size of the image is equal to the size of the object, and you can understand when you stand in front of the plane mirror. Okay. And the another point is the image formed is as far behind the mirror as the object in front of it. The distance of the object from the mirror and is equal to the distance of the image from the mirror. These are the properties of the image formed in case of plane mirror. Next, come to the spherical mirrors. Well, this spherical means comes from the sphere. This is almost a sphere. So spherical mirrors are nothing but the part of the part of a sphere. Okay, so there are two types of spherical mirrors. One is concave mirror, another is convex mirror. This is concave and this is convex. Now see, this is the part of the this if we cut out this part, and we can obtain this type of mirrors. Now in concave mirror, you see the front reflecting surface of the mirror. This is the reflecting surface and this is the back side of the mirror. Reflecting surface is inward. This is curved inward, and in case of convex mirror, the reflecting surface is curved outward. These are the difference. All right. Now see some points you know about the spherical mirrors, as you have to draw the ray diagrams in this chapter, and some numerical sums also there. So you must understand these points of the mirror properly. See, as this is a sphere, so it has a definitely it will be a center. All right. So if I take this portion, suppose this portion, if we detach this part, so it center is this. The center is, this is nothing but a arc of this part or part. So center of this is this point. Similarly, if we consider a center, this is the center, and in case of convex mirror, center will be in this side. In case of concave, center in the front, and convex, center is in the back side. Now the midpoint of this mirror is pole in both cases. It is denoted as P, and this is denoted as C. C is the center of curvature and P is the pole of the mirror. Remember, this pole is the midpoint. Now if a line passing through this pole, as a line is imagined to pass through the pole in both the cases, pole and center, this is called the principal axis of the mirror. This line is, and the distance of this center of curvature to the pole, this CP part, this part is called the radius of curvature in both cases. This is called the radius of curvature of the mirror, and this is the center of curvature of the mirror. All right, in both cases. So now some rays, let's see how rays passes through these mirrors. In case of concave mirrors, from suppose an object is placed at infinity and rays are coming like this. See, this diagram is also given in your book, you see. So these rays are coming and it converges to a particular point, and this point is nothing but, this is called the focus of the mirror. Focus of the mirror in both the cases, you see. So focus it is the focus is found here, and in case of the convex mirror, it will be like this. The rays will be incident and reflected back, incident and reflected back, but we are extending like this. So actually what is this is the focus in case of convex mirror. See here, the focus, these rays are, this ray looks that they converges at a particular point in case of concave mirror, and in this case in case of convex mirror, the rays are appear to come out from a particular point. So both are actually focus, but what is the difference? You see here the rays are converging, all the rays are converging, concentrating at a point. So that's why the mirror, as the rays are converging in case of concave mirror, that's why this mirror is also called converging mirror, remember it. And in case of convex mirror, you see the rays are coming, rays are all are diverging after incidence into the reflecting surface. These are diverging, so these are called actually that's why this mirror is called, convex mirror is called the diverging mirror, as the rays are divergent. This is the main difference you must see, remember. Now see, we have got the focus in both cases. Now see, this is the radius of curvature I have already shown, and this focus is nothing but the midpoint of this radius of curvature, this CP. F is the midpoint of CP. Suppose if radius r, if we denote radius as r, then r must be equal to 2f, and this f is nothing but the distance of f and p. So CP equal to r and FP equal to f. This FP and this F, these are the focal lengths. Distance of the focus from the pole is called the focal length, and distance of the center of curvature from the pole is called the radius of curvature. Alright, so both have a relation, r is equal to 2f. So we can say the focus is the midpoint of the radius of curvature. Anyway, this is the relation between radius of curvature and focus. Now we can see the image formation by spherical mirrors. You see in this table 10.1, the image formations are given at what are the properties of the image formed, and what is image actually. Image is formed by the intersection of the two rays. In ray diagram you can see this method, how the image is formed. Now see here, just given the idea, if at infinity its object is placed at the infinity, image is formed at the focus, and these are the size and nature of the images. Alright, I am showing before drawing the images, how the images are formed in case of spherical mirrors. We need to understand this. See, representation of images formed by the spherical mirror. So number one is, the ray parallel to the principal axis after reflection will pass through the principal focus in case of a concave mirror, or appear to diverge from the principal focus in case of a convex mirror. Okay, both the cases are shown, concave mirror and convex mirror. See, this is the principal axis. Okay, the rays are coming parallel to the principal axis. After incidence, it passes through the focus, and in this case, as it is diverging, already you have seen. So rays coming parallel to the principal axis, after incident it is reflected back. But if we extend this, it will touch the focus. And see, this dotted line is showing in this, and angle INR are denoting. It is already, we in the beginning we discussed the laws of the reflection. So laws of reflection is true for, is holds in every case, and or we can say true for every case. Here also the laws of reflection is applicable. See, it is incident in this reflecting surface, and this is the normal to the plane. Alright, so angle of incidence is equal to angle of reflection. In any case, angle of incidence is equal to angle of reflection. Now see, there are some more ray diagrams are there. With the help of these diagrams, you can draw how the image is formed, or you can show how the image is formed in case of concave mirror and convex mirror, in both. So this you must remember. You see ray passing through the principal focus of a concave mirror. So principal focus of a concave mirror, if a ray comes to the principal focus of a concave mirror, then after incident it goes parallel to the principal axis. In case of concave mirror. So in case of convex mirror also this you see ray, you see the arrow is given. The ray coming from this side. Ray is coming and it has incident in this part and it has travel parallel to the principal axis. So these are some points you must remember before drawing to image. Now see, these are the images. So some images are frequently asked in your exam, so I am showing just one. You can understand the ray diagram. Before drawing, it is a very simple process I am showing. See, it may be helpful to draw the diagram. Easy way with the I am here drawing with the help of ruler and compass for the error-free diagram of the mirrors. So let's take a say I am taking the up to 10 centimeter line, all right, and at the same time I am marking 2 points. This I have marked as center and this I have focus, and this is nothing but the pole of the mirror. Now taking center of curvature, I shall draw the mirror, right. Now I shall draw the object. Objects must be beyond C. In this case, the object is placed beyond C. So I am here taking object size as 2. Now see, these rays are coming from this and rays coming parallel to the principal axis. So make sure that scale is parallel to the principal axis. See, this principal axis is in here. So after incident, as per the first load, see, as we have seen, if a ray comes parallel to the principal axis, after incident it goes through the focus. So we shall use these rules. So definitely it will go through the focus. Okay. Now we have to show the direction of the ray. Ray comes from this object and incident in this reflecting surface. So ray must be in this direction, and after incident it goes to through the focus. So must be in this direction. You see, this will indicate that ray is passing from this side. After incident it passes to the focus. All right. Now another ray come from this object, passes through the center of curvature. See, this center of curvature, now I am showing. See, this is the third case, ray passing through the center of curvature. When a ray passing through the center of curvature, after incident it goes along the same line. You see, this arrow is given, and after incident this arrow is given like this. In both cases, in concave and is in convex also. Actually, in convex, it is coming coming to the center, and as it is divergent, after incident it has returned from this side, but we have extended to meet at the C. This way. Now see, this diagram, ray will come here, and after incidence it is get back to the same straight line, along the same straight line. All right. Now we have seen what we have seen. I have already told that if where the image is formed when the rays from the object intersect, at least two rays. So this is one ray and this is another ray. This is the both has intersected here. So this is the position of the image. Here the image will be inverted. See, alright. And in this case, you see the object is erect, but image is inverted, in real and inverted. You see, if you check this table 10.1, if object I have drawn the second condition. If the object is placed beyond C, then what happened? Image is formed. Position of the image is between F and C. See, I have got the obtained the image between F and C. All right. Now it is diminished. That means the size is smaller. Diminished means smaller, and enlarged means larger. And nature is real and inverted. So see, this image is real and inverted and diminished. See, the size of the image is smaller from the size of the object. All right. So this way you are to draw the error-free diagram, and you can draw these ray diagrams are frequently asked in your exam, so you must draw it properly. And I am here showing with the help of ruler and compass, and you may follow other method. What process you may think that it is easier to follow, you may follow it anyway. So I have shown one diagram from the concave mirror. Though there are 6 diagrams or 5 or 6 diagrams, these are mainly asked. You can try the others. Now another diagram showing, this is also important for the this diagram is mainly asked in case of convex mirror. I am showing this. Similarly, I should draw a line first. All right. Now already I am marking here. It's in 2 centimeter apart. All right. Now in this case, I shall take the center this and draw the mirror this side. Now this is the back side of the mirror. In the starting, I showed that the center and focus of the convex mirror is behind the mirror, not in front of the mirror. So this is focus and this is center. All right, as I have shown here. Now we shall place a object in front of the mirror. Okay, so in the same process, the ray will travel parallel to the principal axis. Make sure the scale is parallel. So after incident, it is reflected back, but reflected back along the focus. So you must place the scale with adjusting the focus, and you draw the ray diagram like this. And also at the same time, you draw the dotted line. These lines are to be shown with the dotted lines. All right. Now show the direction of the diagram ray. See, ray traveled in this direction after incidence. It has reflected in this direction. Okay. Now another ray come along the center. This is the center. Yes. See, this line should be dotted. See, this ray comes from this side, and after incident here, this is the reflecting surface, this is the back side of the mirror. Actually, after incidence, it has get reflected like this, but this part I have extended in the extended in the same line of the center. Okay, now what we have seen, you see, in the front side it has no intersection, but if we extend this rays, it has found to be intersected in the back side of the mirror in this point somehow. So where they intersected, we can draw the image here. All right, this is the position of the image. Now you see, this is the position of the image, and as we can see, these are the table 10.2 gives the nature, position and size of the image. If we actually there are these two conditions only, so they have written two conditions. Now see, if the object is placed between the infinity and the pole of the mirror, so position of the object is between P and F. So see, this is the pole, and object is placed, image is obtained between the P and F, and the object is placed at the infinity. And diminished, size is diminished means smaller. See, this size of the image is smaller than the object. All right, and it is virtual. In this case, it is virtual and erect. In case of concave mirror, only except one case, all the images are real and virtual and erect. Sorry, real and inverted. And in case of convex mirror, these are virtual and erect. Okay. You'd you'd carefully study the table 10.1 and table 10.2, then you can understand the nature of the images. Okay.